Okay, so we are jumping all over the place in our textbook, and we just finished studying all the different rules of differentiation, and you guys had your test on that. So now it's time for us to look at what the derivatives of the trig functions are. Now, trig functions are what we refer to as transcendental functions. So they're different from the other functions that we have studied this year, all which were algebraic functions. And the reason that we haven't looked at the derivatives of the trig functions yet is that we can't just apply like the power rule to find the derivative of sine or cosine. We are going to end up using the rules that we've previously studied and have in our toolbox, but we're going to first derive what the derivatives are of the 6 trig functions. Remember, the 6 trig functions are sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. And I think I'm going to split this lesson into a few different videos. So we're going to look at deriving the derivative of sine and cosine in this first video, and then we'll move on to the other trig functions in another video. So for finding the derivative of sine of x, I give you these two facts. The fact that the limit as x approaches sine of x over x is equal to 1, and you can see that by looking at the graph, right? That's the graph of sine of x over x. And as x is approaching 0, we can see that the function is approaching 1. And then also that the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. And again, I'm giving you the graph of that function, and you can see that as x approaches 0 from the left and from the right, the graph is approaching 0. So we're going to come back. We need these facts in order to help us derive the derivative of sine and cosine. So we'll reference these again. Okay, so to find the derivative of sine, we're going to go back to our good old limit definition of the derivative. Remember, the limit definition of the derivative says that the derivative f prime of x is equal to the limit as h approaches 0 of the difference quotient, f of x plus h minus f of x all over h. And remember, when we were using the limit definition before for finding the derivative of the functions, our goal was to get the h. We would use algebra to try and get that h in the denominator to cancel. Unfortunately, that's not exactly what we're going to be doing for finding the derivative of sine, but we are going to use the limit definition. So if we have f of x equal to sine of x, then f prime of x is going to be equal to the limit as h approaches 0. And this is a little bit long of a derivation, so I'm probably going to end up adding a page. So if you're following along, you just keep that in mind. Okay, so the limit as h approaches 0 of sine of x plus h minus sine of x all over h. Like, okay, well, what do I do now? Well, remember our handy dandy trig identities? We know how to rewrite sine of x plus h using our angle sum identity. And if you were in my class last year, you remember we had a little rhyme for helping us remember our angle sum identities. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. So if you remember, sine of x plus h is going to actually be equal to the sine of x times the sine of h plus, said that wrong. will be the sine of x times cosine of h plus the cosine of x times the sine of h. And then we still have the minus sine of x. I'm not going to use the parentheses around the argument. It's just one extra thing to write. Okay, so we rewrote the sine of x plus h using the identity. This is what that's equal to. Okay, and now by the commutative property of addition, I am going to rearrange the terms that we have in the numerator. So I am going to rewrite the numerator as the sine of x times cosine of h minus the sine of x plus cosine of x times the sine of h. And that's still all over h. And then now by the associative property of addition, I'm going to group sine of x times cosine of h minus sine of x. And notice that in sine of x times cosine of h minus sine of x, we have a common factor of sine of x. So I'm going to factor out a sine of x. And then here is where I'm going to add a page because I'm not done yet. All right, so now I'm going to use a limit property. Well, actually, before I apply the limit property, I'm going to split up this big fraction into a sum of two fractions. So we'll have the limit as h approaches 0 of sine of x times cosine of h minus 1 over h plus the cosine of x times the sine of h all over h. And now I'm going to apply a limit property that you guys are familiar with. So since we're taking the limit of a sum, that is equal to the limit of each part of the sum. Okay, and notice that we are taking the limit as h approaches 0, but in each of these limits, there is a factor that does not have an h in it. So we can actually treat sine of x and cosine of x like they're constants, and we can pull them outside of the limit. Because if we're thinking about taking the limit as h approaches 0, the sine of x isn't going to really do anything and the cosine of x isn't going to really do anything. It'll be whatever the limit is times the sine of x or times cosine of x. So I'm going to pull out sine of x, multiply it by the limit as h approaches 0 of the cosine of h minus 1 all over h, and then pull out cosine of x times the limit as h approaches 0 of sine of h over h. Okay, great. Now you're probably thinking, well, now what? That looks messy. But remember, I gave you those two facts before that I said we're going to reference again. So remember, the cosine of the limit as x approaches 0 of the cosine of x minus 1 all over x is equal to 0. Now let's just think about replacing all those x's with h's, and we know that this limit right here is going to go to 0. And then the limit as x approaches 0 of sine of x over x is equal to 1. And just again, think about replacing all those x's with h's. And we can say that this limit is equal to 1. So we would end up with sine of x times 0, which is going to be 0, plus cosine of x times 1, which is just cosine of x. Okay, so guess what? The derivative of the sine of x is cosine of x. So f prime, so if, I'm going to write it out this way, if f of x is equal to sine of x, then f prime will be equal to cosine of x. Okay? So the derivative of sine is cosine. I suggest, because this is not the easiest derivation, I suggest just memorizing that the derivative of sine is cosine. Now we're also going to derive the derivative of cosine. This is the only, these two are really the long derivation, so I'm going to cut the video and do another one for the other parts of the lesson, or deriving the other derivatives of the other trig functions. But the derivative of cosine we find in a similar way. So again, we're using the limit definition of the derivative. So f prime will be equal to the limit as h approaches 0 of cosine of x plus h minus cosine of x all over h. And then using the angle sum identity for cosine, sine, cosine, cosine, sine, cosine, cosine, sine, sine. So cosine of x times cosine of h minus sine of x times the sine of h minus cosine of x. And if you are stressing out right now because you don't remember your identities, I will be giving you the identities that you will need. Like I'll give you a little trig identity cheat sheet. Okay, so again, by the associative property of addition, I am going to rearrange the numerator. So I'll have cosine of x times cosine of h minus cosine of x minus sine of x times the sine of h all over h. I can group those two terms together by the associative property of addition. It's very similar to the derivation of the derivative of sine. So I'm going to do this. I'm going to factor out the cosine of x from the two terms that I just grouped. And then now applying the limit property splitting this into two fractions. Oh, I'm sorry, I'm just going to go ahead and split this into the two limits. So I'm splitting into two fractions, a difference of two fractions, and I'm also applying the limit property where, since I'm taking the limit of a difference, I can split that into a difference of two limits. And then again, since we are taking the limit as h approaches 0, we can treat cosine of x and sine of x like constants and pull them outside the limits. And then we can reference our facts from above. So remember the cosine, the limit as x approaches, we have to go up farther. As x approaches 0, cosine of x minus 1 over x is 0. And the limit of sine of x over x as x approaches 0 is 1. So this will go to 1. This will go to 0. So we would have cosine of x times 0 and then minus sine of x times 1. So guess what? The derivative of cosine is going to be negative sine. So if f of x equals to the cosine of x, then f prime will equal to negative sine of x. So you want to memorize that as well. Okay, so I'm going to